think I did once. All right. Sorry, I kind of missed the first part of this explanation, but okay. What if I said x is less, the third and final case for and, x is less than 1 and x is greater than 3. So what numbers are less than 1 and greater than 3? No. Less than 1 are all these numbers. Greater than 3 are all these numbers. What numbers are both less than 1 and greater than 3? None. How did we graph nothing on Friday? Left a blank graph. So these little floating arrows aren't actually my answer. They're just to help me think about the answer. They have nothing in common. There's no overlap. So there's no number where these are both true at. So there is no solution. Okay, that's the three cases for and.
You just put no solution if it's just blank.
If you're graphing, you put a blank graph. If you're not graphing, yeah, you put the no solution symbol. Remember that thing? You could write no solution, I guess. It'll work. Okay, now the ors. Let's do x. I'm going to stick with the 1 and 3. Let's do x is greater than. Let's do x is less than 1 or x is greater than 3. Okay, this one's going to kind of confuse you probably because we just did all the ands. So x is less than 1 looks like that. X is greater than 3 looks like that. Okay, because it's an or, they don't have to have anything in common. If the numbers are covered by either of them, it's okay. So does 0 work for this statement? Yes, because 0 is less than 1. Doesn't matter that it's not greater than 3 because it's an or statement. Is 0 less than 1 or greater than 3? Yes. So in other words, we're going to use, if either of them covers it, we're going to use it. So we're going to use all this, and we're going to use all this. So it looks exactly the same as my floaty lines. Floaty is the technical term.
Is it actually?
Yes, extremely technical. Am I joking? Does floaty sound serious to you?
No, Mr. Jordan, but your voice sounds very serious, so, and I don't want to test that. I'm going to argue with the teacher.
All right. I guess I could have been using the or symbol. All right, so on this one, x is greater than 1, looks like that. Or x is greater than 3, looks like that. Remember on the and, we only used the where they both were at over here. But what happens on the or?
It's just one.
Okay, is 2 greater than 1 or greater than 3? Yes, it's greater than 1. Doesn't matter that it doesn't work on this one. So if on the or, if either line covers it, it's part of the answer. So the only thing that's not covered is anything out here. So it's basically, it is this line is the answer. And we've got the last case coming up. The weird one, the weirdest one, I should say. X is greater than 1 or, I'll use the or symbol. X is less than 3. Okay, x is greater than 1, that would be all these numbers, or x is less than 3, that would be all these numbers.
Just a solid line,
Yeah, that covers everything. Because what number can you think of that doesn't work for this statement? Like,
Number.
is a million greater than 1 or less than 3?
Yeah.
Yes. Is negative a million greater than 1 or less than 3?
Yes.
Yeah, it's this one. So everything works. 2 is both, but it doesn't really matter. So it's all real numbers, or if you graph it, it's the solid line. Why didn't I put the open circles on this one? Because it's covered. Every number is covered. So like 3, works because 3 is greater than 1, or 1 works because 1 is less than 3. So there are no circles on this one. Alright, that was kind of the new thing. The rest of it's kind of the old thing. But let's look. Page 36, you guys write that down already? What's it say? 1 through 14. Okay, so kind of what I was just talking about is 1 through 6. I had 6 examples on the board, and there's 6 problems on 1 through 6, so that's it. Yeah. So, it's matching. This is kind of hard to do without the floating line. So I'm going to go ahead and make a little rough sketch here. Here's -2, here's 4. X is greater than -2. Somebody's phone's vibrating over here. Or X is greater than or equal to 4. Remember, greater than or equal to had a solid dot. Okay, that's not the answer. We need to figure out what the answer is. If it's an or statement on number 1, what are we going to use from those two? All of it. Okay, if it's an or, it can be this one or this one. If it's covered by either, then it's part of the answer. So basically everything from -2 and bigger is covered. So it's basically X is greater than -2. If it's an or, you can use where either of them are covering it. That's part of the answer. So which option was that?
D.
D, yeah. So on number 3, I'm just doing the odds. X is greater than -2. So that's that one. Let's get the old one out of there. And less than or equal to 4. So the closed dot going that way. Okay, and means both have to work. So where are they both at? Between these two numbers. They're both, see how both lines are covering all these numbers? So right in there. So is -2 included in both of them?
No.
No, that's, so it keeps an open circle. Is 4 included in both of them? Yes, so it stays a closed circle. And then you just draw the line between those two. So all the numbers between -2 and 4, 4 is included. That is, oh, you know, something else I didn't write down. This is how this graph can be written. This is telling me it's greater than -2 and it's less than or equal to 4. So this is just another way of writing the inequality as one combined inequality. This time it's called compound inequalities, like inequalities put together. It's telling me two things at once, bigger than -2 and less than or equal to 4. So all the numbers between those two. That's what it looks like. What option was that? Somebody said it. F? Yeah, okay, F. Number 5. Okay, X is greater than -2. Oops. So that would be open circle at 2 going right. That's a big circle. And or, this time it's an or, less than or equal to 4. So it's kind of like the last one, except for instead of an and in the middle, it's an or. Which option? What numbers are covered by that?
That'd be all.
All, yes. That was my 6th example that I put on the board. Every number is covered because it's an or statement. If either line is covering it, it's going to be covered. And the lines together are covering everything. So it's a solid line, all real numbers, symbol, or so option.
5 is and, not 4.
Oh shoot, that was 6. Let's see, okay. That wasn't 5, my bad.
So if you get,
X is less than negative 2. I was looking at the wrong problem. X is less than negative 2 and greater than or equal to 4. Okay, what numbers are less than negative 2 and bigger than or equal to 4? None. So that's the blank graph, which is A. No solution. Oops, no solution. That's option A. Alright, accidentally did 6 earlier. What's 7? Fraser, is that how you pronounce that? Fraser first, I don't know, it sounds weird.
It sounds German to me,
Okay, anyway. Evergreens often used for Christmas trees grow in regions 5 and 6 of the climate map at the beginning of the section. Write a compound inequality to describe the average annual low temperature, T, of the following areas. So they're telling us at the beginning of this lesson they have information on razor firs. That sounds weird. So the question is, if the trees grow between regions 5 and 6, what temperatures does it grow between? Like, what's the lowest temperature?
-20
And what's the highest? 0. Do you guys see where you got that from? -20 is the lowest temperature on on 5. We're on top of page 34. For region 5, -20 is the lowest. For region 6, 0 is the highest. So the range of temperatures is between -20 and 0. How can I write that as a inequality statement?
X is greater than or
T for temperature.
T is greater than or equal to -20
And less than 0,
yeah,
but
less than or equal
to 0, but you can write it all in one. So the temperature is everything between -20 and 0. That's where the trees like to grow.
Is that less than or equal to?
They're both less than or equal to. So the temperature could be greater than or equal to 20, -20, and it's less than or equal to 0. So this is saying T is bigger than -20.
But isn't that a less than though?
-20 is less than T.
Oh.
So could you please swap the
For 8, no, 8's different. It's
You have to use 30.
8 is an or statement, so it's just two separate. It's got to be smaller than this one or bigger than this one. Yeah.
might be like a dumb question, but where did you get the 20 from?
Yeah, sure.
Well, I knew.
That's still confusing me though.
Thank you for
This is saying at the same time that T is bigger than -20 and it's less than 0. So it's got to be between those two numbers. Saying remember, we talked about this earlier, saying -20 is less than T is the same thing as saying that T is greater than -20. Like saying that you are younger than your dad is like saying your dad is older than you.
So which one's the variable?
T.
Yeah, but
T can be any number between those two. Average temperature can be anywhere between those two. Anyways, number 3, number 9. This has also something new. Well, 7 and 8 are kind of unique. They're a little bit weird, but you guys try and figure it out. Okay, solving for X in this problem. There are 3 sides quote unquote, 3 things. We want to get x by itself in the middle.
-2 from each side.
-2 from everything. So I'm going to -2 in the middle, -2 on the left, -2 on the right. And that gets x by itself. Did it ask us to graph this?
Yeah.
Okay, I'm not going to be too picky on the graph. Just put, this is basically means x is everything between 1 and 7. So I'm just going to put 1 and 7 on the graph. I'm not going to put every number. This is saying x is greater than 1, so we're going to put an open circle at 1. This is saying x is less than or equal to 7. So it's basically all the numbers between those two, between 1 and 7. And that would be the graph. Okay, number 11 is an or statement. So you just solve both of those separately, kind of like Friday. There's 2 sentences that you solve separately. 3x minus 8 is less than or equal to 7, or 2x plus 5 greater than 7. So we're just solving 2 things separately. So get x by itself, add 8. Divide by 3. Over here we'd subtract 5. Divide by 2. Okay, when I go to graph this, I'm going to use the floating lines. Make sure I get it right here. Got 1 and 5. Supposed to be greater than 1 or less than or equal to 5. Okay. If it's an or statement, what are we going to use? Everything. And what's covered? Everything. So it's all real numbers. So our final answer is a solid graph and the all real numbers symbol. Which is supposed to be like a fancy R kind of like that. I don't really care how you draw it.
Everything has to be fancy. Why can't it just be normal?
That's what
It's just who I am. I'm just fancy. What's so funny? Think that's funny?
No.
I never look at this either because I'm always supposed to look this way.
scared of the middle.
You guys could probably get away. Never mind. Okay. The people on the left could probably get away with something. But they would never do that. They're all saints. 13. Both of these are the answer. The graph, the solid graph, and the all real numbers are the answer.
You're confusing, sure.
It's
He's a
confusing.
very deep person.
Sure. There's a lot to take in on this one. Okay, on 13 there's 2 separate things, but there's an and between them, so let's solve both of them first. You guys go ahead and get a head start. I know you guys can solve that, right?
Yes, sir.
Yeah, I'm not
I
very
can,
speaking.
but anyone else.
Did you get the same thing I did?
I looked down for 2 seconds and I looked back up and everything was working.
Same here.
I got it.
Really, 2 seconds.
You were very fast writing this word.
It's actually like the joke of your look at your paper.
Heck. Alright, we gotta figure out what this is on the graph, simplify the answer. We got -4 and 4. So less than or equal to 4 looks like this. Greater than or equal to -4 looks like this. Okay, if it's an and statement, what are we gonna use?
It has to be between both of them.
I'm just kidding.
Only where they're both at, so everything between -4 and 4. So the graph, the final answer is between -4 and 4. We can simplify, I probably won't worry about it, but we can simplify this statement up here, x is less than or equal to 4 and greater than or equal to 4.
Can you swap
And
this?
just one little inequality. It could be written like this also. I'm not gonna grade on that, but it's a little simpler way to write it. Okay, then I was gonna jump to 17 after that, but I think I'm gonna let you guys work on that. Yeah.
So we're just having
Or
one
AC.
for 14?
Yeah, we'll do 1 through 14. That's fine.
Oh, so only one.
Yeah.